So here we are looking at how to decompose rational expressions with repeated linear factors in the denominator. So if you look at this denominator here, if I factor it out, I need two numbers I can multiply to get positive 1. So a product is equals to 1, and the sum is equals to negative 2. And those numbers have to be negative 1 and negative 1. So that means my factors are going to be x minus 1, x minus 1, or simply x minus 1 squared. So now I'll come and write my equation. So I have, let me write my original equation. I have x plus 2 over x squared minus 2x plus 1 is equals to, I'm going to introduce the a and b, but now I need to know what to write in the denominators. I have these two of them, but the way I write it, I'm going to follow this rule. This is what I have to use whenever I have repeated factors. So that means this, I'm going to keep increasing the powers, power 1, until I get to power 1, then power 2. So this is x minus 1, and I could write it as to power 1, and this is x minus 1 to power 2. And now, see, this to power 1, I don't even have to write power 1, but it's okay. So now I need to get the LCD, and I'll write it here on the side. So the LCD is going to be the higher power. They are the same, but one has a higher power or higher exponent. So it's going to be x minus 1 squared. So now the next thing I'm going to do, I'm going to simplify the right-hand side. And in doing that, I need to look at the denominator and see what is missing in the denominator. What do I need to multiply to get the same LCD of x minus 1 squared? If I look at the denominator of a, I need another x minus 1. So I'll do that at the bottom and on top, but I'm just going to do it on the on top. And because here I'm just going to write x minus 1 squared. When I do the top, this is going to be a x minus 1. That needs x minus 1 in the denominator, but whatever you do in the denominator, you also do it on top. And then plus b stays the same. So that's what I have. I'm now going to simplify what I have right here. I'm going to distribute. So I have ax minus a plus b, and this is equal to, so x minus 1 squared, and I'm going to write my original equation here, x plus 2 over x squared minus 2x plus 1. And note that this denominator, see, this is the same as that denominator. So that means if the denominators are equal, the numerators are equal. So I'm going to write here x plus 2 must equal ax minus a plus b. So if that is the case, then I can equate the coefficients. Like here, a must equal the invisible one here. So those ones have to be equal. So that means a is equals to 1. I've already found the value of a. And then on the other side here, I can write this in the same way. I can just write it as b minus a. And all that is going to equal this value here. those two will equal 2. So that means b minus a, we know a is 1, is equals to 2. So that means b is equals to 3. So when I have gotten the value of a and the value of b, I can come here and write my final answer. So I'll just write x plus 2 over x squared minus 2x plus 1 equal to a is 1 over x minus 1 plus b is equals to 3 x minus 1 squared. So that is the final answer right there.